So question number 10. Question number 10. Match list 1 soil classification symbol with list 2 soil property and select the correct answer using the code given below the list. So GW. That is GW is what is GW? GW is well graded, well graded, well graded gravel. And for well graded gravel, uniformity coefficient CV is greater than 4. So for A, it will match with 2, and B is SW. SW is well graded sand, and for well graded sand, C is greater than 6, so it will match with 1. Option number C, ML, silt of low plasticity. Silt of silt of low plasticity. So soil having low plasticity. So it will match with uh, and low plasticity. So it will match with 3, and D is Cl, that is clay of low plasticity. So in terms of compressibility, uh, the silt is soil having low compressibility. So in terms of compressibility, um, the clay will be less compressible than silt. Okay, so clay of low plasticity and soil having low compressibility, or maybe soil having low compressibility. So 10, option number 2, 1, 3, and 4. So this will match with 4, 2, 1, 3, 4. Option number B. So 10, option number B. So in terms of plasticity, if we talk, so clay has more plasticity than silt. So clay will have more plasticity than silt. So C will match with 3 only. This is the only option. It has low plasticity. Clay doesn't have low plasticity. It has high plasticity. So C will match with 3. Okay. And D will automatically match with 4. Okay. So this is question number 10. Now question number 11. Let me resolve. Now question number 11. This is question number 11. Match list 1 soil with list 2 type and select the correct answer using the code given below the list. Fine sand. Fine sand is fine grained soil or coarse grained soil. Fine sand is silt is fine grained. Peat is organic soil. So A, B, and C. This is B is silt. So this is fine grained soil. Fine grained soil, and B will match with 3. C is peat. Peat, and this is organic soil. Organic soil. So C will match with 4. And A is fine sand. Fine Sand, it is not expensive soil, then it will automatically match with, that is coarse grained soil. Coarse grained soil. So this will match with 2, 2, 3, 4, 2, 3, 4. Option number B. So 11, option number D will be the correct answer. If we make the list, so let me make the list. Boulder, cobble, coarse grained soil, coarse grained soil, and that is fine grained soil. Fine grained soil. In fine grained soil, there is two soil, that is silt and clay. Silt and clay. Silt and clay. And in coarse grained soil is gravel and sand. Gravel and sand, that is coarse grained soil. And gravel and sand, for gravel, there is coarse gravel and fine gravel. Coarse gravel, there is coarse gravel, and fine gravel. And sand is coarse, medium, and fine sand. Coarse, medium, and fine sand. Okay, these are the classification. So boulder size greater than 300 mm. Cobble is in between 300 to 80 mm. And the gravel, size of gravel, 80 to coarse is 80 to 20 mm. And fine gravel is 20 to 4.75 mm. And sand, that is coarse sand, is 4.75 to 2 mm. And the medium is 2.0 mm to 0.425 mm. And fine sand is 0.425 mm to 0.075 mm, that is 75 micron. That is 75 micron. And silt is 75 micron to 75 micron to 2 micron. And this is less than 2 micron. Okay, so coarse grained soil, sand and gravel. So sand lie between 4.75 to 75 micron. This is mm. And gravel is 82 gravel, 82 what, 4.75 mm. So coarse grained soil ranges from 80 mm to 75 micron, and fine grained soil ranges from 75 micron less than 75 micron. Okay, fine grained soil. and coarse grain soil is 80 mm to 75 micron. Cobble is 300 to 80 and boulder is greater than 300. So this is the classification on the basis of size. Okay. Now question number 12. Now question number, let me clear all this. Okay. Question number 12. Question number 12. So question number 12 is match list 1 symbol with list 2 soil and select the correct answer using the code given below the list. So ML is silt with low plasticity, soil with high organic content, inorganic silt with small compressibility. Okay, so A, 3, B, SM. SM is sandy silt, silty sand. Okay, so B is 1. C, peat, soil with high organic content with high compressibility. So C is match with 4, and D match with inorganic silt with large compressibility. D match with 2. So 3, 1, 4, 2. 3, 1, 4, 2. 3, 1, 4, 2. 3, 1, 4, 2, C. So C will be the answer. C will be the answer for 12. For 12, C will be the answer. For 12, C will be the answer. Okay. Now question number. Now question number. Now question number 13. Now question number 13. So now question number 13. Consider the following statement. First statement is the minimum value of group index for the soil can be taken as 0. Yes, the minimum value can be taken as 0. What is group index? GI is 0.2A plus 0.01 BD plus 0.005 AC, where A is equal to the fraction which is smaller than 25 micron, and if that will be x, then x minus 30, x minus 15, x minus 15. B is, that is uh, x minus 35. C is x minus 20. C is x minus, I think it is, C is x minus 40. In this case, this is liquid limit. X is liquid limit. Okay. And this is the range from, this is actually 15 and this is 35. This is 35 and this is 15. And its range is 0 to 40, 0 to 40, and this is uh, 0 to 20. Okay. And this is IP minus D is IP minus 10. Okay. If any term goes negative, if any term is less than 0, that will be dropped. Okay. So the minimum value of group index, the minimum value of group index for the soil can be taken as 0. Okay. And for the maximum positive value of group index of soil is 20. This statement is also correct. Okay. So both statement is correct. So option A will be the answer. Option A will be the answer. Okay. So now question number, this is also from 0 to 20. So now question number, this is all about question number 13, question number 14. Question number 14. What is question number 14? Question number 14 is consider the following statement. Consider the following statement. First is for well-graded sand, the coefficient of curvature should lie between 1 to 3. Yes, for well-graded sand, for well well graded sand, Cu must be greater than 6 and Cc must be less than 1 and less than 3 and greater than 1. Okay. So second statement, a soil having uniformity coefficient is smaller than about 2 is considered as uniform. Yes, this statement is also correct. Cu is nothing but D60 by D10, and if it is equal to 1, then the soil is uniformly graded or poorly graded, because D60 and D10 is exactly equal. If D10 and D60 is nearly equal, then also it is called uh, poorly graded soil. So a soil has uniformity coefficient is smaller than 2 is considered as uniform or poorly graded soil. Okay, so both statement is true. So option number A will be the answer. Okay, question number 14A. Question number 14A. Now question number, let me erase this. Question number 15. Question number 15. On analysis of particle size distribution of soil, it is found that D10 is this, D30 is this, and D60 is 0.8 m. The uniformity coefficient and the coefficient of curvature as given by the particle size distribution curve are respectively. So you know that Cu, coefficient of uniformity, is D60 by D10, and D60 is 0.8 and D10 is 0.1. So this is 8. And Cc is equal to D10, that is D30 square divided by D10 into D60. So D30 square is 0.3 into 0.3 divided by D10 is 0.1 into D60 is 0.8. So that is 9 by 8. This is 1.125. So option number D will be the correct answer. Okay. Now question number 16. Question number 16. Which one of the following statement is correct? Grain size is primary criteria for classification of coarse as well as fine grained soil. No, it is not for fine grained soil. So this statement is wrong. Grain size is primary criteria for classification of coarse as well as fine grained. So it is primary criteria for coarse classification of coarse grain soil, but not fine grain soil. That's why this statement is wrong. Second statement is grain size is the primary criteria for classification of coarse grained soil. So that statement is true, correct one. Okay. Next, C, plasticity curve classifies coarse grained soil. No, this tell about plasticity, tell about compressibility, and okay. So this is not related to grain size, coarse grained soil. Okay. Option D is plasticity characteristic relate to classification of coal. No, this is also incorrect. So option B is the correct answer. Okay. This is all about question number 16. Next is question number 17. Question number 17. Consider the following statement. A conspic conspicuous break in the continuity of a grain size distribution curve indicates a mixture of soil from two different layers. Yes, this statement is correct. Next, a steep grain size distribution curve indicates prevalence of nearly uniform grain size. Yes, this is also correct. A flat grain size distribution curve indicates certain range of passing grain size. Yes, this statement is also correct. So option number A will be the correct answer. 17, option number A. So let me explain about the grain size distribution curve. For grain size distribution curve, we plot graph like this. This is percentage finer. and this is size. In this side, size is decreasing, and in this side, size is increasing. Okay, so if the curve look like this, so this curve is C, and if the curve is looking like this curve is suppose A, and this is exactly following the same fashion. And if this curve is E, and if this curve name is B, and the another curve is D, then the name of these curve is, that is curve A. What curve A represent? Curve A represent well graded soil. Well graded soil. Curve B represent poorly slash uniformly graded soil. Okay, and C, curve C represent poorly graded fine soil. Poorly graded fine soil. And curve D represent gap graded soil. Gap graded soil. If at this point, if this point, this is diameter of particle is dA, and at this point diameter of particle is dB, then in this case, from I take it A1 and A2, it is A1 dA2. So we can take in curve D, in curve D, flat part A1 A2, A1 A2, flat part A1 A2, A1 A2 represents, flat part A1 A2 represent this part we are talking about, this part. Okay, flat, we are talking about this part. uh, Flat part A1 A2 represents missing particle, missing 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 particle of diameter, between, dA1 and d I think this is dA2, so this is dA2. Okay, because on this axis this is percentage finer. So suppose if this is 10, if this is 10%, so 10% of particle have diameter less than 10% of particle has diameter less than dA1, and also the 10% of particle has diameter less than dA2. So from this, from dA1 to dA2, the particle is, there will be no particle. Okay, so from dA1 to dA2 there is no particle, and therefore the finer, percentage finer is 10 for this size and this size also. Okay, so this is gap graded, or particle is missing in between dA1 and dA2. Okay, so answer is A. This is all about question number 17. Now I am clearing this all. We'll discuss question number 18. Question number 18. So question number 18 is A semi-log plot is used to represent the grain size distribution of a soil sample. Yes, this is true. Statement 2. In semi-log plot, wide range of grain size can be accommodated. Yes, this statement is true, and this statement is also correct explanation of this statement 1. So option will be A. So statement 1 is true, statement 2 is true, and statement 2 is correct explanation of statement 1. So option A will be the correct answer. Okay, question number 18, option A. Now we will move to question number 19. Let me clear first question number 19. Okay, question number 19. Arrange the following soil with respect to increasing order of realizable friction ratio. Okay, so friction is uh, friction is present in case of sand, and the friction is very less in clay as compared to sand. So for clay and peat, the friction will be very less. So the minimum is 4. Then clay and mixture, clay, sand and mixture and silt. Then after that, 3 will be there because in this there is some sand. And the next one is uh, sand or gravel. So 2, and last one is 1. This is the increasing order of friction ratio 4 3 2 1. 4 3 2 1. Option number D. 19. Option number D. Okay. Now question number 20. Now question number 20. Let me clear. Okay. Now question number 20. So question number 20. Consider a following sample for which test yields the following result. Passing 75 micron 62 liquid limit plasticity index. As per the group index classification of soil, what is the soil condition of the above soil sample? So that is group index is equal to 0.2 A plus 0.01 BD plus 0.005 AC. So A is 62 minus 62 minus 35. 62 minus 35, this is 7 and 227. B is 62 minus 15, and this is 7, this is 4, and this will be lie in between. B must lie in between 0 to 40, so we will have to take, this implies that B must be equal to 40. And C is, that is C will be plasticity index 35, sorry, liquidity index, that is 35 WL minus 40. So this is equal to 35 minus 40 less than 0. So this term will be dropped. This term will be dropped, and this value taken as 0. And D is IP minus 10, and this is 14 minus 10. This is equal to 4. So group index is equal to 0.2 into A is 27 plus 0.01 into B is 40 into D is 4 plus 0.005 into A is 27 and C is 0, and this will give you the value 7.0. So which soil is this? So let me classify general evaluation of soil, general evaluation of soil, and group index of soil, group index of soil. So if general evaluation of soil, if it is good, then the value of this is 0 to 1. If it is fair, then the value of group index will range from 2 to 4. And if it is poor, then the value of group index ranges from 5 to 9. 5 to 9. And if it is very poor, then it ranges from 10 to 20. So 7 lies between 5 to 9. So the soil will classify it as poor. So this is option number A. So 20, option number A. Okay. Now question number 21. Question number 21. This is a repeating question. So the standard plasticity chart by Casagrande to classify fine grained soil is shown in the figure. Okay. So the area mark P represent that is clay of high plasticity. CH, clay of high plasticity. This range is clay of intermediate plasticity, and this range is clay of low plasticity. That is silt of high plasticity or organic soil of high plasticity. That is silt of intermediate plasticity or organic soil intermediate plasticity. That is silt of low plasticity or organic soil with low plasticity. So this is CH. CH, what is CH? Clay of high, clay of high plasticity. The inorganic clay of high plasticity. Answer will be A. 21. Answer will be A. Okay. Now question number 22. Question number 22. Consider the following statements. A soil can be identified in the field by visual examination. All soil can be. No, all soil cannot be. Okay, this is all soil. So this is not true for all soil. So all soil can be identified in the field by visual examination. This is wrong statement. Fine grained soil can be identified in the field by visual examination and touch. No, not fine grained. This is coarse grained. Okay. Fine grained soil can be identified in the field by dilatancy test. Oh, this statement is correct. Okay, this statement is correct. By visual examination, only coarse grained soil can be identified. Yes, statement 4 is correct. So 3 and 4 statement is correct. So option number C will be the correct answer. Okay, option number C will be the correct answer. So question number 22, option C. Okay, now question number 23. Now question number 23. That is suitability number. What is suitability number? The grain size distribution of the grain size distribution, the grain size distribution, the grain size distribution of the backfill material of the backfill backfill material is an important factor, is an important factor, is an important factor that controls that that controls the rate of that controls the rate of densification density densification. Okay, the second point is Brown, that is scientist name Brown, in 1997 has has defined a quantity called called the the suitability suitability number for rating backfill, for rating 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 backfill as Sn is equal to square root of 1.7 square root of 1 upon d50 square plus 1 upon d20 square plus 1 upon d10 square. So this is 1.7 into 1 upon d50 is 1 mm. So this is 1 square? No, the weight for 50, it is 3, not 1. This is 3. So this is weight is given 350 to 3. So 3 upon 1 square plus 1 upon D20 is 0.5 square plus 1 upon 0. D10 is 0.08 square. And when you calculate this, it will be 21.7. This is around 22. So suitability number is 22. D will be the answer. Okay. This is all about question number 23. Now, question number 24. The Unified Classification System, UCS, okay, is based on the recognition of the type and predominance of the constituents considering grain length, no, gradation, yes, it may be, elasticity, no, non-commutative, no, that is gradation. B will be the answer. 24, B will be the answer. Okay, so the explanation for this question is the the unified soil classification, USC system classify the soil, classify the soil according to first particle size analysis, particle size analysis, both size and gradation, both size and gradation, both size and gradation. Two, plasticity, characteristic, characteristic. It is compressibility. Okay, size is about coarse grained or fine grained. Size tell you about coarse grained or fine grained, fine grained soil. Gradation tell about well graded or well graded or poorly graded. And compressibility tell you about high compressibility and low compressibility. Okay, so this is all about question number 24. This is all about question number 24. Now question number 25. Question number 25. So what is the grain specific gravity for humus type soil? So for humus type soil, humus type soil, humus type soil generally have a specific gravity less than 2, and the specific gravity less than 2 is only option number B. So answer will be B. Okay, so here the chapter 2 is finished now. Chapter 2 is finished now, and this question is asked in ESE 2024. ESE 2024. So remaining question we will not doing the 2025 question and 2026, which is held on 8/5 2026. Okay, so we are not taking the question of engineering services exam 2025 and 2026. Okay, so this is all about chapter 2. Thank you, everyone. Thank you.